represent the incredible energy and complexity of the atmosphere, which often goes overlooked. Scientifically, thunderstorms are the result of specific meteorological conditions that lead to the development of towering cumulonimbus clouds, heavy rainfall, strong winds, thunder, and lightning. To fully understand thunderstorms, it's essential to break down the building blocks that lead to their formation, the stages of their life cycle, and the various types that can occur. Additionally, thunder and lightning, two hallmark features of these storms, involve fascinating scientific processes that I've touched on in a previous video, but we'll go into in a little more depth in this one. Thunderstorms also have significant environmental impacts, influencing ecosystems, the atmosphere, and even the climate. At the heart of every thunderstorm are three critical ingredients. The first is moisture, the second is instability, and the third is lift. We'll get into all three of these concepts. These elements work together to create the towering cloud formations and turbulent atmospheric conditions necessary for thunderstorms to develop. So first off, moisture is crucial because it provides the water vapor that will eventually condense to form clouds and precipitation. This moisture typically comes from bodies of water such as oceans, lakes, and rivers, where evaporation adds water vapor to the atmosphere. The amount of moisture in the air can obviously vary greatly depending on the region and weather patterns, but generally higher humidity levels will increase the likelihood of thunderstorm development. Now, second, instability refers to the tendency of air parcels, small volumes of air, to rise if they're warmer than the surrounding environment. In an unstable atmosphere, the air temperature decreases rapidly with height, meaning that air at the surface is much warmer than the air above it. When surface air is heated by the sun or by warm ocean currents, it becomes buoyant, so it then begins to rise. As it ascends, the air cools and condenses, forming clouds. The greater the instability, the more vigorous this upward motion becomes, which is why thunderstorms tend to form in warm, unstable environments where the surface is significantly warmer than the upper atmosphere. Lift is the final ingredient, and lift refers to any mechanism that forces air to rise. Lift can be provided by a variety of factors, such as weather fronts, the boundaries between different air masses, terrain, mountains and hills can force air to rise, or the convergence of air at the surface. As air rises, it cools and condenses, leading to cloud formation, and if conditions are right, the development of a thunderstorm. Once these building blocks are in place, a thunderstorm begins its life cycle, which consists of three stages: the cumulus stage, the mature stage, and the dissipating stage. Each stage is characterized by distinct processes that govern the growth and eventual decline of the storm. The cumulus stage is the first stage of a thunderstorm's development. It begins when warm, moist air starts to rise due to the presence of lift. As the air ascends, it cools and condenses into water droplets, forming what's known as a cumulus cloud. The cloud grows vertically as long as warm air continues to rise and add moisture. At this stage, there is no precipitation, as the updrafts within the cloud are strong enough at this point to hold the water droplets and ice particles aloft. This stage can last anywhere strength of the lifting mechanism and the amount of moisture that happens to be available. The mature stage is the second and most intense phase of the thunderstorm's life cycle. Now, during this stage, the cloud has grown into a towering cumulonimbus cloud, often reaching heights of 30,000 to 60,000 feet or more. The updrafts in the cloud are powerful at this stage, transporting large amounts of moisture upward. At the same time, downdrafts develop within the cloud as heavy raindrops and ice particles begin to fall, dragging cooler air with them. This combination of rising and falling air currents leads to the formation of strong winds, heavy rainfall, hail, and lightning. The mature stage is when thunderstorms are at their most violent, with the potential for severe weather such as tornadoes, flash flooding, and damaging winds. The final stage of a thunderstorm's life cycle is the dissipating stage. During this phase, the storm begins to weaken as the downdrafts overpower the updrafts. Without rising air to feed the cloud with moisture, the storm loses its energy and it starts to collapse. Precipitation decreases and the cloud begins to dissipate. While thunderstorms can last anywhere from 30 minutes to several hours, most storms follow this three-stage life cycle, progressing from cumulus to mature to dissipating. One of the most striking features of thunderstorms is the phenomenon of thunder and lightning. Lightning, as discussed in the previous video, as I mentioned, is a sudden discharge of electrical energy that occurs when the electrical charge within a thunderstorm becomes unbalanced. As the updrafts and downdrafts within the storm move water droplets and ice particles around, they create friction, which generates an electrical charge. Over time, the storm develops regions of positive and negative charge, with negative charge typically accumulating at the base of the cloud and positive charge at the top. When the difference in charge between these regions becomes great enough, a rapid discharge of electricity occurs, resulting in a lightning bolt. Lightning can occur within clouds, between clouds, or between the cloud and the ground. Thunder is the sound produced by lightning. Without lightning, there is no thunder. When a lightning bolt occurs, it heats the air around it to temperatures as high as 30,000 degrees Celsius. That's about 54,000 degrees Fahrenheit, which is hotter than the surface of the sun. This extreme heat causes the air to expand rapidly, creating a shock wave that we then hear as thunder. The speed of light is much faster than the speed of sound, which is why we often see a lightning flash before we hear the thunder. The time delay between the two can be used as an estimate of the distance of a storm, as I'm sure you've heard. Every 5 seconds between the flash of lightning and the sound of thunder represents roughly 1 mile. The thunderstorms come in various types, each with unique characteristics depending on the environmental conditions that led to their formation. Single-cell thunderstorms are the simplest type and are often short-lived, typically lasting less than an hour. They consist of one updraft and one downdraft, and usually produce localized rain showers and maybe occasional lightning. Multi-cell thunderstorms are more complex and consist of several individual storm cells clustered together. Each cell is at a different stage of development, so while one cell may be dissipating, another is in the mature stage. This gives multi-cell thunderstorms greater longevity and can result in more prolonged and widespread rainfall, along with the potential for severe weather such as hail and strong winds. The supercell thunderstorm as a cyclone, which can lead to the formation of tornadoes. Supercells are capable of producing large hail, damaging winds, and significant tornadoes. Unlike other types of thunderstorms, supercells can last for several hours and maintain their intensity over long distances. Squall lines and organized convective systems are long bands of thunderstorms that form along or ahead of cold fronts. These systems can extend for hundreds of miles and produce a continuous line of thunderstorms, often accompanied by strong straight-line winds, heavy rainfall, and occasional tornadoes. Squall lines are particularly dangerous because of their potential to cause widespread wind damage and flash flooding. Thunderstorms, while a necessary part of Earth's atmospheric processes, can also have significant environmental impacts. The heavy rainfall associated with thunderstorms can lead to flash flooding, as I mentioned, especially in urban areas where drainage systems can become easily overwhelmed. This can result to damage to infrastructure, loss of property, and unfortunately, loss of life. The strong winds generated by thunderstorms can knock down trees, power lines, and buildings, leading to widespread damage. Lightning from thunderstorms is also a major cause of wildfires, particularly in dry regions where vegetation is easily ignited. These fires can spread rapidly, destroying forests, grasslands, and homes, and impacting wildlife and ecosystems. Additionally, thunderstorms contribute to the formation of nitrogen oxides, a group of highly reactive gases that play a role in the formation of ground-level ozone and contribute to air pollution. Now, on a more positive note, thunderstorms also play a role in maintaining the health of ecosystems by redistributing heat, moisture, and nutrients. The rainfall from thunderstorms helps to replenish water supplies in rivers, lakes, and reservoirs, supporting both human and animal life. In some regions, thunderstorms are the primary source of rain during the dry season, making them absolutely vital for agriculture and food production. Thunderstorms are complex and powerful weather systems that result from the interaction of moisture and stability and lift in the atmosphere. Their life cycle, from the cumulus stage to the mature stage and finally to the dissipating stage, illustrates the dynamic processes at work in the atmosphere. Thunderstorms can take many forms, from simple single-cell storms to powerful supercells capable of producing tornadoes. Thunder and lightning, two defining features of these storms, are the result of fascinating scientific processes that involve the release of massive amounts of electrical energy and heat. While thunderstorms can have destructive environmental impacts, they're also essential for maintaining the balance of the Earth's ecosystems. Through continued study and understanding of these storms, scientists can better predict their behavior, mitigate their dangers, and appreciate their role in the natural world. If you've enjoyed this video, please remember to like, share, comment, and subscribe, as it really does help the channel grow. Until next time.